Hello, this is Rodolfo Eric Angat, your teacher in Earth and Environmental Science. Today we'll be learning about solar energy and Earth's magnetic field. Our essential question for today is, how do the Earth's magnetic field protect the planet? Or how does it protect us too from the harmful effects of the radiation from the sun? This lesson covers standard 1.1.4, but it also covers the related standards like 1.1.1 and 1.1.2 and 1.1.3. In this lesson, we aim to accomplish the following competencies. I can identify the process that allows the sun to produce energy. I can explain why Earth has magnetic field. I can differentiate nuclear fusion, nuclear fission, and combustion from each other. I can explain why the Earth's magnetic field and ozone layer are important. I can explain how sunlight reaches Earth. And I can explain why sunlight is important to life. Hopefully, at the end of this video, you can all answer this or you can all accomplish this competency so that you'll get a good grade in our MC assessment. Let's start by describing the sun. The sun contains 99.8% of the mass of the solar system, and together with the other planets and other objects in the solar system, they all revolve around the barycenter of the solar system. The sun produces sunlight through the process of nuclear fusion, and the sunlight that the sun produces through this process of nuclear fusion can travel through the vacuum of space. How can it do that? Because sunlight can travel in the form of radiation or electromagnetic wave. When you were in middle school, you've learned about the three types of heat transfer. And one of those types of heat transfer is radiation. Radiation is a type of heat transfer wherein medium is not needed for heat to travel. And this is how sunlight reaches Earth. The two other types of heat transfer are conduction, wherein a solid material is needed in order for heat to travel, and heat can travel fastest in conductors like metals. And the last type of heat transfer is called convection, wherein fluids are needed to enable heat to travel. Fluids include gases and liquids, and this is the process that is mainly responsible for weather and climate. And we'll be learning those things in the future. The sun is powered by nuclear fusion. In nuclear fusion, small atoms combine together or they fuse together to form a bigger atom and a lot of energy. And we benefit from this energy by having our sunlight. Sunlight can travel through space because sunlight can travel in the form of radiation. Since the average distance from the Earth to the Sun is 93 million miles or equivalent to 1 astronomical unit, it's a little bit far astronomically. Sunlight takes 8 minutes to reach Earth. Now, you've heard about nuclear fusion, but do you know that there are two types of nuclear processes or two types of nuclear reactions? The first one is called nuclear fission or the splitting of nucleus. This process of nuclear reaction is the one that is used in nuclear power plants. Here in the East Coast, we have a lot of nuclear power plants. These nuclear power plants produce electricity. The other type of nuclear reaction or nuclear process is nuclear fusion or the joining of nuclei or the fusing of nuclei, and this is the process that powers the stars, like our sun. The main fuel in nuclear fusion is hydrogen, and hydrogen is also the most abundant element in the universe. This is a nuclear power plant, so nuclear fission is happening here. The operation of nuclear power plants do not produce greenhouse gases, and the most common type of greenhouse gas is carbon dioxide, and this carbon dioxide is the main culprit in one of our major environmental problem, and this is called global warming. A lot of people are supporting the use of nuclear power plants because they do not produce greenhouse gases like carbon dioxide. Instead, they release water vapor or steam. So they are not polluting the atmosphere. However, we have to consider that the main fuel of nuclear power plants is uranium, and it is non-renewable and it is radioactive. If you get exposed to this substance, then you can get sick or you can even die. If a problem happens in the plant and a meltdown happens, then the environment surrounding it would not be habitable for thousands of years. That is the problem with nuclear power plants. Nuclear power plants still use nuclear fission because nuclear fusion, which is more powerful than nuclear fission, is still uncontrollable. Our scientists still do not know how to control the process, thus, it is only used for mass destruction like in making bombs. This is how nuclear fission happens in nuclear power plants. The main fuel is uranium-235, and this uranium-235 is bombarded with a free-moving neutron, and it splits into barium and krypton, and in the process it produces a lot of energy, and this energy is used to turn water into steam, and the steam is used to turn the turbine or to propel the turbine and make the generator produce the electricity. Again, this is used in nuclear power plants. Now let's go back to the sun again. Remember, the sun is powered by nuclear fusion, and in nuclear fusion, small atoms fuse together to form a bigger atom, and a lot of sunlight is produced or energy is produced. And this sunlight or energy travels in space in the form of radiation. The chart that you see now on your screen is called the electromagnetic spectrum, and it is composed of different wavelengths. We have the radio, microwave, infrared, visible, ultraviolet, X-ray, gamma rays. The shorter waves contain more energy, and they are more deadly or deadlier than the longer waves. So the shorter waves here are ultraviolet, X-ray, and gamma rays. So ultraviolet radiation can cause cataract and skin cancer if you get exposed too much. Infrared, visible, and ultraviolet are the three main components of sunlight. Now the rest, they all come from space, and they can affect us. Of course, the one that can greatly affect us are the one with the shorter waves. Again, those are ultraviolet, X-ray, and gamma rays. Visible light is the one mainly used by plants in order to produce food. It is also the one that allows us to see things. Now, this visible light is really very important. Without it, we won't be having food on Earth. That's a visible light. And visible light is the one used in photosynthesis. Now, solar radiation, as mentioned before, is composed of infrared, visible light, and ultraviolet radiation. Aside from those types of radiation, other types of radiations like gamma rays and X-rays also come from space, and these things are very deadly to us. So how come we are still alive when all of these things are bombarding Earth on a daily basis? The reason why we are still surviving on Earth is because Earth has a force field. This force field of Earth is called Earth's magnetic field. This magnetic field protects us from the bombardment of solar winds containing a lot of different types of radiation. So this magnetic field deflects the radiation away from Earth and maintain Earth possessing the Goldilocks condition. Now, this is an artist sketch on how our planet's magnetic field protects us from the solar flares. Earth's magnetic field protects us from space radiation, especially the gamma rays and X-rays. You must be asking, how come Earth has a magnetic field and other planets don't, like Mars? It doesn't have the magnetic field anymore. So we cannot just go there and live there because we are not protected from this deadly radiation. So what gives Earth this magnetic field? The answer to that question is that when you were in middle school or in elementary, you've learned about the different layers of Earth. The innermost layer of Earth is the inner core, and it is solid. It is the hottest, yet it is solid because of all the pressure of the different layers above it. Above the outer core is the liquid inner core. Both the outer core and inner core are mainly made up of iron. Now, in the outer core, this outer core is made up of swirling liquid iron, and this swirling liquid iron is the one that produces Earth's magnetic field. So if this is not here, then Earth will not also have the magnetic field. Remember, it's the outer core. Now, because of the Earth's magnetic field, so the deadly radiation from space are filtered out. So the good radiation, the visible light, comes to Earth, reaches Earth, and allows the plants to produce food for all of us. Sunlight allows plants to perform photosynthesis, wherein carbon dioxide combines with water to produce glucose, which is the food, and oxygen release, and that's the one that we breathe in. Life on Earth is possible because plants use sunlight energy to produce food through the process of photosynthesis. The food produced by plants starts the biosphere's food chains and food webs. Now, in my explanation earlier, I mentioned that sunlight is composed of visible light and ultraviolet radiation and infrared. How about that ultraviolet radiation? Is it good for us? No, it's not. If you expose yourself to too much ultraviolet radiation, then you can get skin cancer or you'll get cataract, and that's not a good thing. But the good thing about it is that our planet has a protection from this ultraviolet radiation. And this protection is called the ozone layer. The ozone layer is a layer of ozone gas or O3 in the stratosphere that prevents the ultraviolet radiation from reaching Earth. However, due to man's inventions, a lot of man-made substances or chemicals have been released into the atmosphere like CFCs, halons, chlorine and bromines, These gases, these man-made gases, has destroyed a lot of the ozone gas in the ozone layer and caused it to become so thin and a hole to form in different areas around the Earth. And this resulted to the lower protection from ultraviolet radiation. It's not a good thing. The ozone layer is very important because it protects us from the ultraviolet radiation, but it is being destroyed. These are the things that destroy the ozone layer. This is the O3, which is the ozone gas, but it is being destroyed by chlorine and CFCs. Because there are people who care though, they they fought for the protection of the ozone layer by stopping the production of those things that produce gases that lead to the destruction of the ozone layer. So they thought about it, and then because of that, they stopped the production of such inventions like refrigerators, air conditioning systems, uh, fire extinguishers, spray nets from using those destructive gases. We still have these products up to now, but they're using something that does not destroy the ozone layer. In 1987, the Montreal Protocol called for a ban on all products with CFCs. And because of that, now our ozone layer is healing. It's now getting better. Thank goodness. Oh, this is a new word. It's called combustion. We've discussed about nuclear fusion. It's the one that powers the stars like our sun. Nuclear fission, it is the one that powers the nuclear power plants that allows us to have electricity. How about this combustion? Combustion also produce energy, light and heat, just like the sun. When you burn something, you produce light and heat, right? The difference between combustion and the nuclear processes is that in combustion, you need oxygen. You need oxygen to burn the fossil fuel. The fossil fuel can be coal, oil, or natural gas in order to produce light and heat and the byproduct carbon dioxide and water. Carbon dioxide is the most common greenhouse gas. It is one of the reasons why we have been so worried about global warming. And that is why we have to lessen our consumption of our fossil fuel, not only because they are non-renewable, but also because they produce a lot of greenhouse gases. Again, combustion use oxygen in order to produce light and heat, and in the process it produces carbon dioxide and water, while nuclear fusion and nuclear fission don't require oxygen. Finally, let's have this one will be differentiating renewable from non-renewable energy. Most renewable energy get their energy from the sun, like the plants. We can have firewood and burn this so that we can produce heat. But originally the plant got its energy from the sun. The wind, the wind is blowing because of the heat from the sun. Hydropower energy, we have snow, rain, sleet, precipitation because of solar energy. And solar energy also have an impact on geothermal energy. On the right side, we have the non-renewable energy. The most common non-renewable energy are the fossil fuels. Fossil fuels include coal, oil, and natural gas. So oil, coal, and natural gas are all fossil fuel. Among the three, oil, coal, and natural gas is the cleanest while coal is the one that is considered as the most polluting. Another example of a non-renewable energy is nuclear. Remember when we are discussing about the nuclear power plant, the fuel of this is uranium and it is non-renewable. I hope this equipped you with the knowledge in order to get a good grade in our MC assessment. Once again, thank you so much. Bye-bye. Enjoy learning.